Welcome to lecture 10, and the topic of this lecture is testing a diode. Testing a diode. First of all, the DMM diode test position. Many digital meters have a diode test function that provides a convenient way to test a diode. When set the diode test, the meter provides an internal voltage sufficient to forward bias and reverse bias a diode. This internal voltage may vary among different makes of DMM, but 2.5 volt to 3.5 volt is a typically range of the values. The meter provides a voltage reading or other indications to show the condition of the diode under test. So, when the diode is working, the red lead of the meter is connected to the anode and the black lead is connected to the cathode. So this is when the diode is forward biased. If the diode is good, you will get a reading of between approximately 0.5 volt and 0.9 volt, with 0.7 volt being typically for forward bias. So we will see in our next figure when the red LED of the meter is connected to the anode and the black LED is connected to the cathode in the case of forward bias. And in this slide we will discuss when the diode is defective. When a diode has failed open, you get an out of range OL indication for both the forward bias and the reverse bias conditions. For a forward bias check of a diode is good, you will get a resistance reading that can vary depending on the meter's internal battery. Many meters do not have sufficient voltage on the ohm setting to fully forward bias a diode, and you may get a reading of from several hundreds to several thousand ohms. For the reverse bias check of a good diode, you will get an out of range indication such as OL on most DMMs because the reverse resistance is too high for the meter to measure. So this is a figure. In this figure you can see this is a digital multimeter and this is a point of voltage or ohm and this is a ground point. Some meters have included fuse and some meters do not have included fuse. So this is a continuity of this meter. So the first figure when the forward bias test. So figure A, forward bias test. In this figure you can see a black LED is connected with the cathode and red LED is connected with the anode. When the diode is forward biased, you can see for the case of silicon 0.70 voltage display in the digital multimeter. So in the reverse bias condition, the polarities are reversed. A black LED is connected with anode and a red LED is connected with cathode. You can see OL display in the meter. So figure C, forward and reverse bias test for an open diode give the same indication. So if the diode is open, you can see a OL indication in the digital multimeter display. So the black LED is connected with cathode and red LED is connected with anode. So if the case of reverse bias, then same the OL display in the meter. So the figure D, forward and reverse bias test for a shorted diode give the same 0 volt reading. So in the case of forward or reverse bias, if the diode is shorted, then you can see 0.00 volt display in the meter. So this is the 4 condition that we have discussed in previous slide.